because thank goodness can only tell you what to do, and I'm not a grower that actually have to deal with this disease, because it is a very difficult disease to combat in orchards. So if you're not successful, don't be dismayed. It is really difficult, as is all soil-borne diseases, both for growers to control and manage the disease in orchards, and for nurseries to keep their nursery free of Phytophthora and to provide growers with Phytophthora-free trees. So I would like to first just start off with what are oomycetes, because I think most are familiar with Phytophthora as a disease of macadamia. So when we refer to oomycetes, they are actually fungal-like organisms, and what makes them different from fungi is that they have swimming spores, and which is why we call them water molds. So from that also you can deduce that they like water, and they phylogenetically more similar to brown algae than to true fungi. So a different group of organisms as pathogens. So if we look at the different oomycetes that are known to be damaging to tree fruit crops, that is Phytophthora as a genus, but also Pythium. So Pythium previously was a very large genus with more than 150 species and a lot of difficult names, but in practice it means that some of them were pathogenic, some non-pathogenic, and some can even serve as biocontrol agents. So important that if you have an oomycete, damage to the tree can differ, and some can actually be beneficial. So just to confuse us all, the taxonomists decided to split the genus Pythium into 3 different genera. So nowadays there's a lot of new genera and species. If we look specifically what species are damaging and genera to macadamia, it is Phytophthora cinnamomum, which most of you will be familiar with, that causes a disease that's also referred to as slow decline, causing stem cankers and root rot. And then within our research, we also identified Phytophthora parvispora that causes root rot. It's very closely related to Phytophthora. As for the Phytopythium species, there is one Phytopythium vexans that causes root rot and stem cankers also on macadamia. So that was first reported by Cobus Serfontein in 2017 and was confirmed in our research project. So we have ongoing efforts in developing detection methods for Phytopythium vexans in nurseries, because we believe it's not good for a nursery to distribute these trees. But unfortunately, this specific species is not as easy to identify as Phytophthora cinnamomum, so this is still work in progress. And then, based on our pathogenicity trials, there are also some Globisporangium species that may be damaging to young trees. At this stage also, we know that the genera other than Phytophthora are damaging to seedlings in the nursery and to very young trees. We are not sure what the effect is on orchard mature trees, bearing trees, but important on small and young trees, they can be damaging. So for the rest of the talk, I'm going to focus on managing Phytophthora and these other oomycete diseases. So the good news is that all of the management strategies will be effective against all of these different foreign names that you see on this slide. The only thing that we're not sure about is the sensitivity or susceptibility of rootstocks and our chemistry. So that is also ongoing research to check whether those that are effective against our Phytophthora species will also control Phytopythium. So I would like to spend a few minutes just on the symptoms, because I think unfortunately there's a lot of misdiagnosis. As Runel also showed you, there are a lot of yellow trees, I think, that are sometimes being identified as Phytophthora. So one of the main symptoms of Phytophthora on macadamia can be stem cankers, as you can see on these slides, with the red gumming that you see there being indicative of active stem cankers. So this is one symptom that the pathogen can cause. The other destructive symptom is root rot. And as you can see here, you really want a macadamia tree should have massive root rot amounts when you dig up the roots. The other photos on the slide just shows from trees that are infected by Phytophthora and where the feeder root system is completely destroyed. So these, both your stem cankers and your root rot, then will manifest in foliar symptoms that then can include yellowing. But for me, it's not always easy just looking at the foliar symptoms, deciding whether you do have Phytophthora-infected diseases. So definitely send Gerda and her team a soil sample and a root sample so that they can check if it actually is Phytophthora. Don't just go on foliar symptoms, but some characteristic, especially if you have root rot, is leaf abscission. So your canopy will get thinner and the leaves usually at the top of the twigs will fall off and start die back. But then again, if you have a stem canker like on this tree, there will also be leaf abscission, but you will still have the leaves at the top of the tree. So, and I think what makes it difficult identifying the disease is also that rootstocks cultivars different, and also by environmental conditions. So these are organisms that really like wet conditions. So sometimes you may not have conditions in the soil that are conducive for root rot, but you may get stem canker infections if there were sufficient wounding. This is just work from Femi Akinsami's group in Australia, just showing the differences in susceptibility. I think we know in South Africa all that 816 is very susceptible. As you can see here on the left-hand hand, you have the uninoculated seedlings, and here all of the inoculated seedlings, and you can see the large effect on reduction in root volume on 816. So we are currently busy starting trials to just compare NALMAC to Beaumont and H2 and A4 as susceptibility both to the root rot. And Femi's group also looked at the stem canker susceptibility, which corresponded for these different seedling rootstocks being both susceptible to root rot and stem cankers. So if we look at Phytophthora management specifically in orchards, as with all disease management, it is important to use an integrated disease management strategy, of which the first is organic amendments, then irrigation management, inorganic nutrition, specifically those nutrients that will promote root health, soil management, especially when establishing new orchards, ridging is very beneficial because it helps drainage. The less free moisture and moisture accumulation you have in your soil, the better. If you're going to plant on a clay soil, you will have most likely problem with Phytophthora. So site selection is very important where possible. Rootstock material, very important, purchase from certified nurseries that regularly trace that the trees are Phytophthora free. And then lastly, chemicals, with which I will end. So I'm just going to say a bit about some of these management strategies. Specifically irrigation, don't over-irrigate because these are water molds. You are going to favor the pathogen, but also don't under-irrigate because the stress plant is going to be more susceptible to Phytophthora. And then also, I know this is not always practical, but try and micromanage sick trees, because usually you've got not all of the trees being sick, but those that have a reduced root mass is also going to get wetter over time, and that favors the disease. So those trees are just going to get sicker over time if you cannot find a way to reduce their watering relative to healthy trees within the orchard. Then organic amendments. I know in our other tree crops this is easy to do, and it's not always possible in macadamia, but it definitely helps in the integrated control, applying compost and mulches, because this improves your soil aeration and soil structure over time, but also specifically microbes that are beneficial in suppressing the pathogen. I think this is a better approach than trying to apply biological control agents to the soil, because the mulch and the organics really have a great buffering capacity both against pathogens but also abiotic stresses. Then something that we often use in avocado specifically is applications of calcium, specifically gypsum or calcium nitrate. And this is important at the establishment of orchards. Be careful when you want to apply this. I'm not going to, my soil chemistry is very bad, but consult a soil chemist, because if you end up applying too much calcium, you're going to replace your potassium and magnesium, and then you're going to run into various other nutrient problems. I think this is one of the limitations of using calcium. And interesting, the mode of action of this application, especially if you have a clay soil, over time it helps to improve the structure and aeration of the soil, and it also has a mild fungistatic effect against the sporangia. And importantly, it doesn't have anything to do with a pH change. Phytophthora functions over quite a wide range of pH. Then when we come to chemical control, it still remains one of the most important things, especially once you start having symptomatic trees in your orchard. The integrated management, very important once you don't have symptoms, but unfortunately once you start having symptoms, you will need chemical control, and there in the macadamia industry it is difficult because currently there is no products registered. So I'm just going to tell you about chemicals that we are busy trying to register and starting registration trials on, and they are effectively used both in avocado and citrus. So important because of the symptoms that Phytophthora causes, both destroying the feeder roots and in severe cases where you have the cankers that damages the phloem and xylem. It's going to take at least 2 years to really recover that tree. I think if you did apply chemicals and your tree recovered in 3 months, then it likely wasn't Phytophthora that was the problem there. The tree really needs time once application starts, so also don't start giving up after the first year of application. The trees, when you see that foliar symptoms that I showed you, is going to take some time to actually recover. And definitely very important, don't only rely on your chemicals, you need to use the integrated strategies that I've also shown. And if symptoms are very advanced for the foliar and the stem cankers, then you may not be able to save the tree. As I already said, no chemicals. I unfortunately cannot recommend anything. I can just tell you what we're hoping to achieve in future once we have these chemicals registered. So currently on various tree crop chemicals that are effective is your mefenoxam metalaxyl and your phosphonates. And then there's also new actives that have recently been registered in the USA, being oxathioprylin and fluopicolide. They are all single-site fungicides that are applied as soil drenches that are highly effective, but they are, due to resistance development, they will be sold eventually in combinations with other products to prevent resistance development. So if we look at the feminoxam and metalaxyl, why it is effective is because it relatively moves in soil, and unlike your phosphonates, it can control your soil inoculum. The only disadvantage of this product is that it's very prone to microbial breakdown in the soil. So that is why we recommend that you only apply it once every 2 years, and preferably only once per orchard. And it's also a single site activity, so you can also run into resistance development problems if you apply it too frequently. It's applied as a soil drench. Unfortunately, the product is expensive, so when you get to very large trees, it can be uneconomical to apply it for managing the disease. So moving on to phosphonates. So this is, I think, a very unique group of fungicides that we have had for more than 30 years. There's no report of resistance development yet, and it's very unique that it moves up and down in the tree. There are various formulations available in South Africa. I think the potassium phosphonate is the most familiar and most product names. Then there's also ammonium phosphonate. And the first one that I've listed there, the alkyl phosphonates, was first registered, but because it's still under patent, it's one of the more expensive phosphonate products to use. The potassium and ammonium are more cost effective and they work equally well. So because these products move up and down in the tree, you can apply them in various different manners. They will end up in the roots or in your trunk tissue. So soil, drench, and irrigation applications, I've made there a question mark because there is a lot of unknowns both about the efficacy and the longevity of the products if it is applied to soil. However, I know this is a way that growers really like to apply it because it is the most practical way of applying the products. Foliar sprays, remember when there is severe canopy loss of leaves and you start getting a thin canopy, then your foliar sprays are not as effective because cannot be taken up. And then trunk sprays and paints are used in citrus and macadamia. It doesn't work in avocado. And then trunk injections is still used in avocado. But for macadamias, I think foliar sprays and trunk sprays are the most frequently used in Australia. And then interesting, if you look at the US, they like applying in irrigation and as drenches according to their registrations. The drawback of the phosphonates is residues. Because they are so mobile in the tree, they translocate in a soil sink manner. So we've done a lot of work in avocados. Even if you have no fruit or flowers on the tree, they still end up in your fruit because of the soil sink translocation in the tree. And I will show you some data of our trials where you get less residues with your trunk paints and sprays than with the foliar sprays. So if we look at the time of application for your phosphonates, it's interesting that it differs on the different crops. In citrus, it's applied every 6 to 8 weeks and not applied when you have an active flush, and that is because then all of the phosphonate will go to the active flush and not to your roots and your trunk at the bottom where you want it to protect the tree. In avocado and macadamia, the various application methods is usually targeted according to root flushes, and that again is due to the sink source translocation of the product. So there you are all familiar with the phenological chart of the macadamia, so you want to apply it when there are root flushes, so there's basically 2 application windows. The disadvantage of both of these windows is that they have either flowers or nuts on the tree, which means that's a sink. And the other problems with spraying with flowers is that there has been reports from avocado that it can influence your fertilization of process. So there's a bit of problems that we still need to sort out there. So I'm just going to briefly show you, SAMAC has funded phosphonate registration trials. So we have completed 2 trials with the help of Elsje Joubert and Marita Skuman. These trials are a lot of work. So these were the treatments that we evaluated. We did include a soil drench, and although there's still a lot of unknowns, but we know that this is really something that growers would like to do. We also did a bulk spray and then different concentrations of foliar spray. So we applied most of the treatments in autumn and spring according to the root flush. This last one we did not apply in spring to try and get away from that application to the flowers. And here we increase the dosage to a 0.4% active. So you can do that, but it's very important. Then you have to adjust the pH with potassium hydroxide to 7.2. Otherwise, you are going to get severe leaf burn. And all our autumn sprays were on mature nuts just before harvest. In retrospect, that was not the best application because we went out from the assumption that the mature nuts would not be a sink for the fruit and you won't get a lot of residues. The reason why we don't want to apply after harvest is that work that we did in avocado showed that the trees, when they start bearing fruit, are really susceptible. So during that last period just before harvest, you get a lot of Phytophthora in the roots. So I really don't want to wait until after harvest before you start treating to control the Phytophthora in your roots and in your cankers. So, yeah, a problem with deciding when to apply to get efficacy but not get problems with residues. So this is the results from our trials. So we did one trial in Mikado and one trial in nail spray. So these graphs show you where we did measured root phosphate concentrations. So phosphonates break down in trees to phosphate, which is an anion and actually controls the pathogen. So we can monitor how effective our applications are by quantifying the phosphate in the roots. So you can see in the nail spray trial, the soil drench was more or less comparable to the other application methods. In the Mikado trial, especially in the second year of application, it was not as effective. But I think this is, and it was definitely because that was our Sika orchard. There was not as much feeder roots to take up the product. So I think also taking care if you, in future, once these products are registered, want to use soil applications, you need feeder roots to actually take up the product. We also quantified Phytophthora cinnamomi in the roots, and based on these analyses, there were no differences in efficacy of our different treatments. We did not see any yield differences in the 2 years that the trials were running. But from this, we concluded that all of the treatments were equally effective. And then I think from a market access point, very important here, these graphs shows the residues. So although the MRL for phosphatidylol, which is the residue of phosphonates, is 500, I've drawn the line there at about 160, which is what the specialty supermarkets in Germany would require you to adhere to. So you can see all of the foliar spray treatments in the Mikado trial. We're still waiting for the second year of residue data. Exceeded the German or the supermarket residue, whereas in 1 year, in the first year, it also did so at the nail spray trial. So definitely important take-home message from this work, and it makes sense knowing how the product work is that your soil and your bark sprays result in less residues than when you do foliar sprays. So then just for chemical control on young trees, our recommendations in avocado and on apple, where Phytophthora is also a problem, is that it's very important to treat your young trees because they are very susceptible. And if Phytophthora gets a hand on a young tree, it's going to be difficult to recover that orchard. So rather go for a preventative application. Once one of these other actives are registered as a soil drains, apply that at planting. And then for the first 3 years, apply a phosphonate foliar or trunk spray to really protect your tree, because you don't know whether the pathogen may already be in the soil where you're planting or whether it's going to come in with the irrigation water. Then just ending off with controlling in nurseries. Again, keeping Phytophthora out of a nursery is easier said than done. But the important things are, first of all, water, because with one irrigation cycle in your nursery getting Phytophthora into the irrigation system can cause a large amount of infections. So ideally, a nursery should have 2 dams, one for flocculation and another where the chlorination is taking place. Chlorination is very important and should be monitored regularly, that it's at least 3 parts per million, because again, these are water molds, so they're going to distribute with the irrigation water. And then it's also recommended to actually test your water monthly for Phytophthora in the nursery with 2 traps. And this can be done, you can make this trap that you connect to the irrigation line, and we put lemon leaf baits in there, which Gerda can also help you to plate onto a selective media and identify the pathogen. And hopefully you will not find it, but monitoring in nurseries is really important. As for orchards, don't over-irrigate, which is difficult in nurseries where you have trees of different sizes. Then the growth media is often next to water being the source of contamination within nurseries. Use well-aerated medium. You don't want water clogging. Test each new batch of medium for Phytophthora. Ideally, these should be sterilized in some way, but it's not practical, so testing is the best option. Don't fill your bags close to areas that may be a source of contamination. And then also sanitation, and this comes because all of your oomycetes are in soil, so try and lift your bags at least 30 to 40 centimeters from the soil level, or prevent any soil splash. That's the basic rule for not having it distribute in your nursery and not trees being cross-contaminated within the nursery. And then also regular testing of plants in bags and of your seed bed. So if you can see here, if your seed bed looks like this and it's close to soil, you're going to have soil splash. So be careful of the location of your seed beds within the nursery, and shield them from any soil or dust splash, and regularly test. So I'd like to end with thanking SAMAC for research fundings, growers, Hannes and Elsie, for providing our trial sites. As a scientist, I'm very dependent on doing our trials by growers graciously giving us site to test these chemicals and do the registration work. And then also for MC and Andrew for very useful discussions on Phytophthora of macadamia, because my expertise mainly lies with that on avocado. But I've learned a lot in the past 3 years, and I'm still learning more as I work with growers. Thank you.
Are we still nicely on time, Adele? Thanks. We've got a big good space for a question or two, so you guys are most welcome.
Yes. Ja, het ons 'n mic.
Daar's ou met 'n mic.
Do you know what the impact of the phosphonates have on the soil microbiology?
Yeah, that's a debate that is ongoing. We don't know what it does. We do know it's most active against your oomycetes. It does have some activity against some fungi. So yes, you will likely may have an effect. The thing is that we don't know how long it persists in the soil. I think if you listen to the Australians, why they don't recommend it is that it doesn't persist in soil very long. So when you apply it, it gets rapidly taken up by the roots. But it's definitely an option or a possibility.
That's another question.
In other crops, nematodes sometimes causes an initial infection, and then Phytophthora comes in as a secondary infection. Have you done any work on the correlation between nematodes and Phytophthora in Max?
No, and I must admit I'm a very bad nematologist. Where's Mika or a nematologist? But as far as I know, nematodes are not as on apples. Same with avocado. There's not really parasitic nematodes that's a problem, like on citrus, where I know semi-penetrans is a problem and aggravates your Phytophthora.
Last question, maybe just one. Oh, there's one. 3 guys coming.
Learning that they're active in water, I wondered whether light is also linked to their activity and whether irrigating at night would mitigate their activity if they need both water and light. And so could one retard their activity during the day?
Yeah, I think light in itself is not normal. Sunlight is not very inhibitory to Phytophthora. At what time you irrigate, I think the effect on disease development will depend on how long the soil gets saturated. So sometimes we would, especially if you're like in a clay soil, we would not recommend irrigation at night where possible, because it's going to keep the soil wet for longer, and the pathogen really needs moisture to infect the roots.
Thanks, Adele.